So, good morning, everyone. It is a pleasure to introduce Dr. Rashmiranjan Nayak, a researcher in electronics and communication engineering from NIT Roorkee. He has over 10 years of experience in teaching, research, and artificial intelligence. His main area of work includes computer vision, deep learning, video anomaly detection, and intelligent surveillance systems. He has published research papers in reputed journals and has guided many students' projects. He also serves as a reviewer for leading international journals and conferences. We are glad to have him with us.
Thank you.
Sanjay.
Thank you, Sandana, all the volunteers. So actually, why people are sitting behind? At least they are for some. You are comfortable there. If it's not audible, then you come. Audible, then you sit there. I don't have to disturb you actually. Okay. One rectification, she told that doctor, actually I am not a doctor, I have submitted my thesis, yet to be awarded. Okay, so it's for clarification. So we start now. Okay, should I start now? The session will be like that. I will completely switch over intermediately between PPT and the presentation and the programming part. So, for example, I will just explain few things. After that, I will go for programming. From that programming, I can infer something. Then I go for PPT, something like that. Intermediately, I will change. So, I assume that you all know little bit of Python, little bit of PyTorch, DL frameworks, PyTorch, TensorFlow, NumPy, Panda, C1, Matplot, all the libraries. Even if you don't know, it's no problem because I will tell all the concept, I will give all the codes, everything to you so that you people can utilize it in your research. Apart from that, kindly listen whatever I am going to tell because I am not going to teach or tell something, share experience with you in a traditional way. I will not follow the syllabus actually. I will tell the concept which many people do mistake. Then I will explain that concept so that you people can utilize in it in your research or even if you are teaching also. Apart from that, I will cover so many things. So these are the outlines. First, back to basics means I will explain only one or two concepts. Why CUDA is required, why NumPy is required, why all the tensor platform is required. That is the only things. Within 5 minutes, I will complete that. After that, I will give key conceptual foundation of machine learning. In this topic, I will cover 10 important questions. Even if for any interview, any programming, anywhere you go, 10 important foundation questions I will ask and I will try to solve through the programming. And from that programming, we will get the conclusion also. Apart from that, after that, I will tell research aspect of machine learning. So you people all are listen me carefully because it is very beneficial for me also, for you also. Because we know that being a faculty in any college, it's not always possible to carry the workstation, high-end workstation with you. So nowadays, people are telling that if you don't have any NVIDIA GPU or CUDA workstation, so it is impossible to research. So that part I will clarify here. It is not required that part. Even if I used to work in a system which is 10 lakh plus cost around, so after moving from NIT, I have moved to in such a way that will I am working here only in my laptop only, having 4 GB GPU only, 60,000 laptop sufficient, and IEEE transaction will come. 3 paper I have communicated also. Okay, one also revision one, no minor revision I submitted in that other domain I'm telling, not a high domain actually, complexity domain. Okay, so basically I'm telling that it's not always required that only machine learning research is possible only if you have the infrastructure or platform. So what are the concept I will tell actually, where it's required or not required. Then after that I will tell edge intelligence with key paradigms. I will explain basically edge AI, and from that edge AI also a substitute will come, that is TinyML. So which is the latest field TinyML I will tell. So then I will do one thing, self-assessment quiz. It is nothing but whatever I will explain from that, only 10 questions are there. I will share the link with you people through the team actually. So within 5 minutes you have to submit the answer, and automatically you don't know the answer also. Google said you will get the answer. Google Form. Okay. So it is for you only. Okay, not for me. Then after that we can discuss the questions. Okay. Actually, if you people are one point I will tell, if you people are really want to work or research in machine learning, always prefer the Ubuntu. Okay, I always hand in Ubuntu, but unfortunately my system got all of a sudden I prepared here, so I am using Windows. But there are few problems are there Windows. So that portion I will tell what is the problem basically. It's a practical experience you should know that in Windows. Basically, there are 3 to 4 platforms are there which are people are using. One is PyTorch, another is TensorFlow. PyTorch is the extension version of the cafe, Facebook. Then TensorFlow with Google, Keras platform. Okay, previously it was Keras. So apart from that, we also have Fast AI there, Fast API concept is there, and MindScore is there, Chinese platform that is also rapidly growing. So few platforms are there. But many people are working. We from the academic people we prefer working in Python because it's a little bit of programming easy. Not easy actually. You can try the programming similar manner. Another pattern is TensorFlow. That is also good, very good. But TensorFlow is very good for industrial purpose also. And whatever tiny ML pipeline I will explain, in that I will use the TensorFlow. So why I told you that Windows you should not prefer because the native support of GPU for TensorFlow after 2.10 is not available. So that means you have to always install a virtual VM machine. Okay, so if you do VM machine, then there is a problem of accessing the VM CUDA, the NVIDIA graphics card from that VM machine from your Windows system. So that is the problem. Apart from that, all the programming, CUDA installation, everything through single command line you can do into Ubuntu. Initially it will feel difficult, but it's not difficult. It's very easy. Okay. So I have installed the Anaconda. So Anaconda is a package manager. So basically, you can also go for the Miniconda also, small version of it. So from that Anaconda, I have created different environment. So you people also know there are different environment you can create. So am I clear environment? So basically, for different program, we require different libraries, different DL platforms to isolate the program for interpreting others. So you can do environment. So this is actually a starting point of the research. But nowadays people are not following this portion also. For your research you can do. But for example, we are deploying the program in Jetson or any device. I have also device you can show, as I can show all the devices. So in that case, you need container concept. Okay, Docker concept, container concept. So for this time, I am not going to go inside that. Okay, so the command is whatever environment I have created, always refer the to create the environment by the refer the official documentation. From there you can create all the environment. So I have created all the environment here. One is for TensorFlow, PyTorch, and another is TinyML specific. So you can see this is one of my assumption. You see the names are given in such a way that PT112 means 1.12, Pi 3.10 like that. It's not mandatory, but from my experience, I am telling that if you follow this, there is a less chance of confusing your environment. Okay. So the environment itself by seeing you can tell what is the package actually, main package. So from that PT 1.12 means Python 1.12, then Pi 3.10, then CUDA 11.3, CUDNN, CUDA Deep Neural Network Architect library is there, that is 8.3. Okay. So I can activate one environment. What happened? ये कहाँ गए ये था एक्चुअली इनका केबल में प्रॉब्लम था तो ये लोग ने सही किया था अभी तो दिख रहा था नहीं ये तो आ रहा है, डिस्प्ले आ रहा है, बट ये पीपीटी वगैरह क्यों नहीं आ रहा? अभी आ रहा था, अलग काम कट गया। मैं तो टेस्ट भी किया था, आप देखे थे ना सर, चल रहा था, सारा चल रहा था, मैं तो आज भी चल रहा है।
रख लो। टू तक को सिलेक्ट कर दिया।
It's not extended, it's easy.
अभी सर को ये डिस्प्ले में लिख के ना ये
केवल काढी लगे पहले तो ऑलरेडी मैं ट्राई कर देते
एक्चुअली से जो ऑलरेडी ब्रेकफास्ट करी पड़े से जो एटी जे मैनेज कर
ये तो मेरा डेस्कटॉप आ रहा है,
जी सर।
बट वो स्क्रीन जैसे मैं पीपीटी शेयर कर रहा हूँ ऑल ऑफ सडन कट गया, ये तो आ रहा है। ये मेरा डेस्कटॉप है, वो शायद वो पुराना का नहीं, अभी तो दिख रहा है वही, पीपीटी नहीं आ रहा, मतलब मुझे लग रहा है शायद स्क्रीन मतलब फिक्स हो गया, रिस्टार्ट कर दूं क्या मेरा सिस्टम? मतलब कुछ हवा कथा ना किसी केते थोड़ा करी चाहिए, बट इट्स नॉट लाइक दैट। So while it is getting restart, I can explain one thing. So basically, back to basics, I am going to explain few things. That is why numpy is required. Utility of a numpy. So in that case, I will explain two codes by using only Python without using numpy, and one is with using numpy. So we know that there are ସବୁ ଗୋଟିଲା ଅଟୋମେଟିକ୍ ସେଇଟା ଆକ୍ଚୁଆଲି କ'ଣ ହେଉଛି ନା ସିଏ ଅନ୍ ଅଫ୍ ହେଉଛି ନା, ସେ ଯେତେବେଳେ ହେଉଛି ତାହେଲେ କଟିଯିବ। ହଁ ଆସୁଥିଲା, ବଟ୍ ସିଏ ଖାଲି ହେଲା ଆଉ ଥରେ ଦୁଇଥର ହେଲା ତାପରେ ପଳେଇଲା। ଆପଣ ବି ଥିଲେ ନା, ଏଠି ହେଉଥିଲା। हाँ डिस्प्ले एक्सटेंड रे पड़ी बोधे डुप्लीकेट कर दिया। ओके ठीक है, हाँ हाँ ठीक है, अभी अभी ऑटोमेटिकली कटि जाउछि केमति एबे पछक आछै ना आछै।
देखेला कमल वाल मोटा देखो
हाँ एबे चल जे एक्सटेंड
हां एक्सटेंड नहीं पड़ता
से ऑटोमेटिकली पड़ी जाए।
हां
କିଛି ରହୁନି, ହଁ ଜଷ୍ଟ ମାନେ ଆର୍ମ କରୁଥିଲେ ଏବେ ଯାହା କରୁଛି ସେତିକି। Excuse me. So we can go now. So here actually basically I can see it now comfortable. So I can see here. So basically what happened is, here you can see, so I want to calculate the square of the numbers continuously. So if you go through Python by using for loop only, that means element wise square equal to, then what is the time required? If I go for the vectorized numpy type, then what is the time required? So from that we can say how numpy is making the our computation efficient. So basically I can give you one example. One example that simple multiplication in MATLAB we used to do by using for loop. Yes or no? Multiplication plus addition element wise you do. Just like row column addition multiplication. Yes or no? So if you do that way, apart from that, another concept is that tensor. So if you go for the vector, that vector is nothing but it is basically it is just like a matrix type thing. At a time, element wise multiplication at a single run it will single time it will happen. So that means in for loop sequentially you are going, but in vector it will be at a time all multiplication will be done at a time. So another thing is that TPU, basically tensor. In that case, what will happen? It will be three-dimensional multiplication will happen. So based on that only, there are two CUDA architecture, two graphics are there. One graphics is NVIDIA graphics. CUDA is the library which facilitates the convert the high-end programming to the C++ library program by using Visual Studio as a backend. So it will convert that. So you can use that. So that is done by the NVIDIA graphics. That is nothing but my vector concept. So for tensor, Google has developed its own hardware. That is tensor. So even in Colab you will find the TPU. But the problem is that TPU is available as a cloud platform only. Not hardware is available for public. But Google is using that. So it is faster as compared to CUDA graphics. So you can tell that NVIDIA as compared to NVIDIA, it will tell then TPU is faster. The reason is that three-dimensional vector or indirectly or multi-dimensional vector or tensor can be at a time done. At a time can be execution can be done. Compute can be at a time. So from that, so this program is nothing but you can see both the cases accuracy will be remain same. Accuracy will be remain same, but time taken will be different. So you can see using CUDA. So another thing is that many people will tell that whenever we are doing programming, so my system don't have a CUDA or a GPU, it will not work. My system has CUDA, it will work. So what you will do, always try to add something as a preamble, so that will detect the CUDA. If CUDA is available, then the program will be converted to CUDA, typecasted to CUDA. If CUDA is not available, it will be CPU run. So that is a Python command. If CUDA is available, every program, every syntax automatically typecast using CUDA dot something. That program. So that is required. So even if you are writing any program, so always try to use that. So it will be independent of the platform. And always remember, many cases in real world cases, we train the program using GPU, but inference is supposed to happen in the CPU. Okay. For example, many people will tell that CPU is faster or GPU faster. Actually, CPU is faster. Actually, CPU is faster, but CUDA cores have more small computation and parallelly it can parallel process again ensemble, so that's why it seems to be faster. But if you count quantity wise, CPU is faster or more computational. Okay, just like many people tell which signal is more accurate, analog or digital. Actually, analog signal is accurate because inherently in digital quantization error introduced. So similarly, just like that this is also one where you can find the how collection counter you can use to calculate the basically number of frequencies. Suppose in NLP programming or natural language programming, even if in communication point of view if you are BC background, you can know that randomness concept is there and more frequency the symbols more appearing more frequency will code it in the less numbers. Okay, less number of symbols. So in that case also you can use. So in that case, what will happen? You can count the number of continuous or any phases happening again and again. So in that case, what will happen? By using Python counter, you can count that, and without Python also you can do that by using simply detecting that. Okay, so in that case it will go there. So it will run that program. It will take lots of time also in both the cases. But for pure Python it will take more time, but counter it will take less time. Okay, you can see almost less number. So I will share the codes, no problem. So basically one thing I want to tell, best part of the deep neural, any DL platform is required because we know that in machine deep learning basically we have a forward pass or one is a backward pass. Okay, so from input to output you have to propagate all the weights, so actually calculation will be done again from error will be propagated backward. So error propagated backward is nothing but my change in weight with respect to that neuron you have to calculate. So that is nothing but d by dx something. Okay, dw it will happen. So that is nothing but my differential term. So change with respect to something here with respect to that signal strength. So it is nothing but my gradient. So that gradient, if it is differential equation in continuous domain, it will be difference equation in discrete domain. Yes or no? In the DFT concept. So we will be difference equation to calculate that, to solve that. We require a finite analysis method. So that will be done by the autograph mechanism. So that is the beauty of this library, because without that deep learning is not possible. So autograph means automatically backward calculation will be happen. So even if you are telling that PyTorch or TensorFlow, any program you are writing, every program will be internally converted to a particular graph. That means suppose I am writing y equal to x plus y. If I am writing y equal to p plus q, and that means p and q are two nodes, it will be assigned to the y that value. So it is a computational graph. That computational graph can be static. That means first program will be run, compile, then graphs will be created, just like you create the decision tree like. So graphs will be created. From that graph, computation will happen. That is static. So TensorFlow 1. TensorFlow 1.x. That means TensorFlow 1. So that is the demerit of that. But PyTorch is a dynamic graphic. TensorFlow 2.0 also, 2.x also has dynamic graphic. So that way, computational graph has to be converted into dynamic. So that's why autograph function is required. So apart from that, lots of things, torch vision, transform, all the libraries are PyTorch are required. So I will not explain all the things. So I will simply stop here because I have to say lots of things. The main intention of that to tell you that you people should know what is the importance of CUDA, why it is required. Actually, I was planning to run a autoencoder program in TensorFlow, PyTorch, Mindscore on single tags. I want to compare. But the problem is that if people are not studying deep learning, so that's why I stopped that. So I also tell you that to always you can check, just like I told you. So these are the command you can use. The torch CUDA available or not, CUDA is using your your program is using that CUDA or not, you can use. So now I will tell the foundations of machine learning, basically few concepts I will tell, and parallelly I will try to explain all the things. The first is that why do over-parametric models generalize? That means over-parametric models means basically we know that you people are able to follow me or not? Or am I a little bit fast or something? Okay. So over-parametric models means, what do you mean by over-parametric model? Basically, machine learning is nothing but its estimation of a distribution. Yes or no? It's estimation of distribution. That is, in more depth if you go, it is probability density function. So if I know that, if I know that a random experiment is carried out, that random experiment has a sample space, and I have that sample space, and in that sample space I know the input output pairs, that means xy corresponding xy is I know. From that I can I can estimate the probability density function to model that system environment or model that underlying pattern. So in that case, what I am telling that I know input, I know output, I know the system function or transfer function as per control system or signal system. I know the transfer function or any system. So if you know the input, you know output. So by multiplying that in Laplace domain, you will get the basically nothing but my output response. So that is direct modeling. But here it is ill-posed modeling because you know the by observing the input output, so you have to find the system model. So basically you have to follow the random variable concept. So one thing you should know, random variable is not a random variable. It's not random, it's not variable. The name is like that. Random variable is not a variable. It's not a function. It's not a random. Random variable is a deterministic function. Random variable is not a variable. It's a random process. Okay. So it may be difficult. You may be able to confuse little bit, but you should know that because suppose for example I am throwing a dice. So I whatever function I know from that 6 option only one will come. So my function is deterministic. But why it is random? The nature is that the how I throw that is random. So that's why it's random. Okay. So from that concept, so in classical machine learning concept, when the number of parameters is less than number of samples. So in that case, it's not over parameter model. But in deep learning concept, high-end machine learning models, so number of parameters will be more than the number of data. That means sample. Okay. So whenever many people are telling that we need big data, you people know the big data concept. So always remember, data needs to be big. It's okay, but that only big is not sufficient. I need good and big data. Good means annotation consistency is required. No noise level is required. So if you give the garbage of all the random, all the things at a time, all the things at a time, the model will not learn. So that's why I need good and big size data. Okay, but always good and bad is not good. So I will tell another concept that is tiny ML where small is beautiful. If you know the small data set, that is also okay because we have lots of data. Okay, so in that case it depends upon the application. Okay, so that's why in your sample space needs to be IID, identical distributed. Okay, independent identical distributed. So that means if I am going to design a cat and dog classifier model, in that case only cat images for a single cat is image there. So it's not independent identical distributed. So what I have to do? I have to do different cats. So that's why augmentation comes to picture. And cat I cannot take drop at a time that because it has to be independent. So that's why IID concept has to be followed for machine learning or deep learning model. But one model it doesn't allow obey that concept, that is NLP or GPT concept. In that case, all the heterogeneous data comes to a single picture. So it's dependent upon conceptual why you are telling. That means IID holds good for many cases, but few cases are there. Sample space no need to be IID. That is nothing but NLP or GPT scenario. So here over parameters as per classical things, over parameter models does not need to be generalized. Okay, but as per classical, but in deep learning or machine learning, advanced machine learning part, you will see that more parameter when more parameters than data you will have infinite zero solutions. So classical just predict that whenever more number of parameters are there, what will happen? Severe overfitting will happen and poor generalization will happen. Okay, I will tell poor generalization and severe telling I will tell. So why? But in practice it does not happen. Then why? So actually the model expands in that the solution selection matrix because in infinitely many solutions in sample space it exists. From that it will take only the appropriate solution. So that's why optimizers does not choose arbitrarily. It is though it will follow a particular path. In that it will find the global minima, at least a optima. Okay. So when I'm telling optima, it may be maximum and minimum. But when I'm telling minima, it's loss function only. Depending upon your formulation, it will take two picture. Then gradient based method is preferred because low loss solution will come, stable solution will come, large margin solutions will come. Then I will go to that explanation. Code it. I will explain 10 concepts. I will share slide and code everything with you. Okay. So you listen carefully. I am trying to maximize everything, but lots of time is required. So okay. Actually, the problem is that when you are changing that, okay, I will do at a time. Just one thing. I will open at a time everything. Then we will do. Why it is again? Automatically it is coming.
And the slide is being cut. It gets
Huh.
still.
Shoots. Actually, I will open at it in every program so that I can switch over. This पानी बोतल क्या करती है? Actually, initially I have programmed as a Python file, so I used to use Visual Studio basically. So as a Visual Studio ID, okay, VS Code ID, because you people are also using that Jupyter. But for if you are going to do research, don't do this. It is for training. You use VS Code. Okay, why? Suppose you are got a whenever I'm telling something from my experience only. Okay, so suppose you want to you got a code from GitHub. You want to develop it, improvement upon that. So in that case, you can do versioning. Apart from that, you can compare the code simultaneously. And nowadays, AI help is available on the right hand side of that code where you can ask something and you can get. So use VS Code. Okay, for a tutorial purpose only, I have converted it again to tutorial, and also I have written the few things because I know that many people cannot follow it, write it. So later I will share it so at least they can follow the code. So what we are going to do here, basically we show how basically over parameter model can generalize. So when I am telling generalize means model should have high generalization ability. So that means it should perform well on the on-scene data. It should perform on the on-scene data. So many people, those who are working in biomedical field, you people that all the papers are coming with validation results, which is actually basically wrong. Okay, they are giving validation method, K-fold validation method to justify it, because indirectly your model is exposed to that. So basically, you should have three split always. That is, that part I will explain also. Basically, train, test, validation. Three parts should there. There are so many concepts are there. So basically, I will explain infinitely many zero solution training solution exist. Optimize selects minimum norm solution. Minimum norm solution generalizes better. That means if you are finding that minimum, that norm means that error function is minimum. Then you will get more generalization. So here you can see all the libraries I have taken, and I am not going to explain the concepts. For example, linear regression, logistic regression, decision tree, all many things I am going to use because I never touch any deep learning concept in my whole session. I will not touch. Everything is machine learning. So theory you have to complete it. So I will just tell briefly. Okay, here you can see one thing I have intentionally added, that is np.random.seed. Okay, so always remember, if you are doing any research, any class, always use that function, because your model initialization. I have already told you that random initial weights of that model will be randomly initialized. For that, we are using random initialization means every time if you run the program, every time your output will be little bit different. So that's why if you are writing thesis or paper, you stick that seed concept so that your randomness will be deterministic. That means every time that same initialization will happen. So that means suppose revision came in your paper, so when you modify something, it will not change. Otherwise, you will face problem. Many friends of mine also face problem. So use that random seed. So it's a technique by which you can control the randomness of the initialization. So here we have to generate a true low time signal. Basically, very few samples I am going to generate. All the examples are independent of data sets. I have created their data sets. Okay, created the samples there. So here, what I am doing, true linearly array I am created. That ranges are given. From that, I am randomly splitting them to train and model dimension accordingly. That true function or any function you can tell, I am going to train it. From that train, I will also test it. So it's a basically what I told you. The first one is nothing but my, that means a random function I have created. In two cases, model parameter is 100, but number of samples is 30. So that means it's an over parameter model. Yes or no? So over parameter. So in that over parameter model, so what I have used? I have used that regression method, parameterized regression method. From that regression method, so we will calculate basically how it is overfitting is happening or not. You people also know till now overfitting, underfitting, optimal fitting, you know. But I will clarify. But you might not listen. That is benzyl overfitting or descent, double descent. So I will explain that. One graph is there. I will explain how double descent happen. But it means traditionally how it has to be reduced, and after a certain point it will not reduce. So here you can see basically doubles benzyl overfitting is a phenomenon where what will happen? Over parameter models achieve zero training while still generalize well on the test data. Training loss will be zero, still generalization will happen in the test data. I mean test data performance will be also good. So from that, then double descent means it's a curve actually. From where you can see that it will increase, decrease, then increase, again it will decrease. Just like UJT curve, unijunction transistor curve. Okay, like that value point, peak point, we got similar concept in curve. I will explain that also. So here we are calculating training or testing error we have calculated. So here first one is without regulation. Second one we have calculated reach function, that means norm function, L2 norm. So if I am going to use log function, so you can see I have given exactly the losses I have written also for expansion function, for expansion purpose. So by using that function, so you can calculate. Now compare the weight distribution. So that means for all the cases, you compare the weight distribution. You see here, reach regression has a almost, it's a distribution will be little bit Gaussian shape as compared to linear regression. Okay, so we know that naturally, if distribution has to be equally distributed, ideally case, but it has to be at least follow Gaussian pattern. So you can see it is following that pattern only. So from that, so observation, what we are going to see here, the observation are nothing but training error is zero, even though parameter sample is greater than number of samples. But classical model, classical ML tells that it will not happen. Then test error remains low. That means over parameter model also generalized. Test error remains low. Weight norm is small despite no explicit regularization. That means we don't apply here just like batch normalization. So many concepts are there. It's dedicated. Then optimization implicitly prefers minimum norms. These are things I will explain. Okay. So these are the code basically you can see to explain that concept. So these are the takeaway. I have already told you that classical variance theory predicts that overfitting will happen, but modern generalized due to implicit regularization. Then even though infinitely many solutions exist, gradient based optimized convergence to low complexity, minimum norm, large margin, which is better. Overfit does not guarantee overfitting. That means always it's not true. Generalization depends on which solution optimization selects. That means a gradient based method implicitly prefer the low complexity. So I will explain another concept. That means many people will tell that your model is learning perfectly. How did you know? Now we know from the loss curve. From that loss curve, what are the curves are there? Training loss, validation loss, test loss. Sometimes only training loss they will tell. Model is learning. Okay. So that is not, that is a wrong concept. That means training loss is not equal to the learning. It is not only parameter. Low loss is often treated as a success. Many people will tell it's success, but actually this is the trap where the model starts to behave differently. So, does fitting data imply understanding? On data imply understanding? That means if you are telling that loss is minimum, so that means my model is fitting perfectly. So if it fitting that data itself is telling understanding. So what will happen? So basically there are two concepts: memorization and learning. So from that only you can tell what is memorization, what is learning. So here two objectives are there. From fitting point of view, it is optimization. From learning point of view, that is different. That means how my model is behaving on the validation part or test loss, that is my learning. From that training loss, I can only predict optimization. So that is nothing but my memorization part coming from memorization versus generalization. So basically core idea is learning about unseen data. So that means model should capable of solving the unseen data. Okay, by solving the example, if you are unable to solve the exercise, then you are not a bright student. Yes or no? We all are like that. So that is why model has to be learned. So now we'll again. ये तो किसी भी करने से
इसको
हाँ मतलब
प्रोजेक्ट
ये हर बार ऐसे होगा क्या? तब तो बोंगा है भाई. So this is the same concept. For that reason, I have used regression version. One is highly expressive model, that is decision tree. We know that it's a more robust model as compared to linear regression. So that's why I'm expressive model. So decision tree, you know that a leaf and tree concepts are branches are there. So classification for regression we are using. For classification, basically we use the probability term. For regression, we output will be discrete, continuous variable, just like prediction of the temperature for next 5 days, it will be continuous. But whether it's a cat or dog, it will be classification. Okay. The best part of that concept, what is the function, how it is converted actually. Always use, if you I will tell one thing. In deep learning concept, we use activation function, just like a transfer function. You inside that it will be convert the input output to particular form. So always remember ReLU function. ReLU function we use on the middle. Leaky ReLU, then simple ReLU, dead ReLU concepts are there. So many things are there. We use in the middle layers, hidden layers, never on the output layer. But we use tan as segment function. So basically why we use, because we will have a before that preliminary layer. That means exactly before the last layer we are getting the weights which have infinite number of large variations, just like 1.9999 like that, 10 point like that, all the continuous values. So it cannot do that. So that's why whenever we use that function, it will try to convert to the number of classes probability. That means 1.99 will be converted to some probability, it will be 0.3 or 0.4. For example, even if cat dog classification, cat image if input, though it is zero point 0.9 cat, 0.1 dog is also there from that same image. So that's the probability. So that's why we use that. So in that case, we use basically what I explained, that ReLU layer cannot be used on the outer layer because we need a probability term. So that's why. So here you can see basically seed from here I am using 42 all the programs, so that will be concept, because why whatever done I did write the code for the decision tree, linear regression, nothing. I just import it. Okay, by with the suitable arguments or parameters. So here I am generating the data. The data basically small. In that data, one data I have created small noisy data set. Small data but noisy, noise I have added it. Then I have created, make it train and test flip. Then dense grid for visualization. That means I want to see it. Okay. Then one is perfect optimization for memorization. That means training loss will be 0. So after that, one is imperfect optimization. That means learning in test performance will be reduces. Then we have to bring the quantitative with the results. So if we quantitative in decision tree, training loss is 0. test loss is 0.11. For linear, you can see training loss is 3.50. Then test loss is 0.14. So that ideally we know, you can see it is happening opposite. Yes or no? Yes or no? It is happening opposite way. So that's why it's over. That means though training loss is 0, still my model is performing bad on the test data. Ideally, what should happen? Training accuracy more, loss less, as compared to validation, as compared to test. So then we can compare it in visual way. So you can see perfect training loss is not equal training. You can see it is nothing. It is similar to that adaptive delta concept. You can see similar curve is there, na? Delta modulation. So you can see true function is nothing but my that same function I have plotted here, and training data are the points. Model is nothing but my, it is zigzag in nature. That means you try to catch the function, but it's not unable to catch that path actually. But here higher training loss is better learning. You can see in this case you can do always that line is given na, one line non-link model. What that line actually, this is a boundary actually. Basically whenever we do machine learning or deep learning, we always go for the geometry. I'll explain one example there also. I'll explain. So you can see here. So basically, minimizing training loss is not equivalent to learning. So this is nothing but. So same concept. This is regression problem. For classification also we can do. For classification, here one concept I'll tell. Similarly, I have used all the pipelines. Then similar data I have generated. Instead of classification, regression, I am going for the classification. Here, training loss, logistic regression, decision tree, you can see. Here, what happened? I have used cross validation. Here, training loss, training accuracy is very high, but validation very less. So in that case, I can tell my model is not generalized. That means it is not performing well in the test data. So another concept, cross validation leakage demonstration I will tell. That means always remember, if you want to do some pre-processing, always do after splitting, not before splitting. That means train, this is practical experience. From train, if you are going to split train test validation, always do after splitting you do any transformation, not before that, because indirectly you will get data leakage. That means data will be, the information will be leaked from one split to another split. For example, we know that in signal system, you people your communication background student can know that scaling and shifting is not, order has to be maintained, information will lost. Similar concept. So here scaling inside the pipeline it will not locate. That means after during that model only taking the model training, then you have to do the classification that training. So you can see the result. So cross validation leakage effect, that means without leakage your accuracy is 0.52, with leakage 0.752, but here without leakage it is 0.752. That means always remember, leakage degrade your performance. The model sees test distribution as a statistics. Apparent learning is not real learning. That means it seems to be learning, but it's not real learning, because you have already, because what I'm telling, you want to do transformation, do inside the model pipeline. Here I have done the directly call the function. That's why you are unable to see the model pipeline. Okay, but inside that argument I have only passed. Here you can see. Inside that you have scaling, standard scalar is applied here only in the pipeline. In the pipeline I have applied. But if you are going to write any deep learning model, machine learning model by using TensorFlow or Keras, I will show one or two examples there. So in that case, you always try all the processing part inside the model only. So it will prevent the data leakage. So these are the finding we found, that minimizing training loss is an optimization objective, not a learning guarantee. Learning means minimizing expected risk, while training loss minimizes empirical risk. Overfitting achieves perfect optimization, but poor learning. So that's why overfitting is not required. So next concept, what we'll do, we'll explain the inductive bias. So there are two types of bias. in machine learning, particularly a deep neural network, you see that weight bias concept is there. Many people also know at least. So that is nothing but for giving a offset, initial offset. But this bias is not that bias. Okay, just like we know that biasness is bad. Yes or no? Biasness is bad, but this bias is good. Just like in BJT, without bias amplifier cannot happen. So similarly, here this bias is required. That means without bias learning cannot happen. So that means the concept I am going to that these are nothing but the assumptions for a learning algorithm to use to generalize beyond training data. So the by which the model will generalize over the training data, that concept are known as inductive bias. Without inductive bias, learning from finite data is impossible, because actually for machine learning has to be perfectly learn, we need an infinite sample space. Why? There is a concept known as universal approximation theorem. That means universal approximation theorem tells that if you have a sufficiently large number of sample space or input data, ideally, I can only predict the system or underlying pattern. So that is universal approximation. So from that approximation, the ideal concept is infinitely large solution sample space should be there. But practically we cannot do that. So we need a finite solution. For that finite sample space, that means finite number of input output pairs. From that finite input output number pairs, so we have to train. So if you have to train, we need inductive bias. So the concept will explain why same data, different model, and same model, different data behave differently. These are the concepts we will explain. Okay. So inductive bias can be defined as which enables generalization. I have already explained. Assumption beyond data. That means data is there. Few things has to be assumed. That means model class. Then regularization. What is regulation we are going to optimization. Then drop out. So many things are there. Representation. Representation is nothing but feature extraction content. Okay. The key insight that no inductive bias is no learning. Sorry, I will open it. No problem. सॉरी बार बार होगा क्या करें इधर उधर ये कट जा रहा है. So already I have explained the inductive bias concept. So here I am going to explain logistic regression, then Gaussian Navier bias, then K neighborhood classifier and random seed 42 SBC. From SVM I have used to support vector classifier. So here you can see same data we are generating for all the models. Now let us keep the data set. Then different models, we are calling the different models. Okay. From that, we have to train and evaluate and compare same data, different inductive biases. You will compare here, you will find different accuracy. Now, I want to visualize the decision boundary, because I have already told you that input data has to be converted to latent space. Latent space is nothing but my feature space. In that feature space, model has to get, the classes has to be separable. So that's why there should be a boundary. So that is nothing but a decision boundary. So in SPM linear projection, we calculate PCA components are there. So many things are there. So here so you see here. So first case, so these are nothing but my samples. So in the last case, you see smooth nonlinear bias. You see, basically here classes are distributed both the cases. Here both the cases. But here also similar both the cases. But here the less number of classes are. Decision boundary is perfectly linear. So similarly, now I tell where actually this inductive bias lies. Actually, inductive bias in model where it comes from. So here we will explain train validation test, train cross validation test, nested cross validation test. I will explain. I already told you initially that biomedical people are biomedical signal processing people always give validation results. Why it is wrong? I will explain it. Not wrong. It is not that much of gold standard actually. Here what will happen? We'll keep the same data, evaluation same generalization, bias level different models. That means generalization will be different, then model will be behave differently. Fixed data, here different classes, First one is the explicit train test validation. I have done it explicitly. Then second one is that cross validation plus held out test. Cross validation held out test means, let us assume that I have 100 number of training samples. So I keep 80 as a training, 20 as a test. Test completely on sync to my model. From that training 80, so I will make 8-fold cross validation. So that means first 1 to 70 will be training, 10 will be at 81 to 90 will be my validation. Again it will be 10 to 20, next 10. That is nothing but cyclically my model will be validated from the k fold. That means 8-fold here. Assuming 10 number of years simply. So that in that case, held out test means 20% always they are kept separate. So biomedical people, what they are doing, that held out test they are not giving. They are only giving case cross fold validation. So indirectly, they are indirectly putting some 1 to 2% extra result. So here you can see the third one is the nested cross validation. So this is the gold standard we used to tell. So that means your data will be within that loop your data loader, because always remember in a PyTorch or TensorFlow you have to create a data loader. So data loader is nothing but means it can be directly, you can create the library available, otherwise there are also you can build your own, so depending upon as per your requirement. So in that case you can go for the nested cross validation. That means within the fold it will be again cross validated. And what will happen? And that cross validation will happen the shuffle way. That means it's not a particular order. Every time that one validation happen, training data will shuffle, again it will come. So where it is applicable? It is applicable only for the image, applicable only for the text data. But time series data, it will not meaningless. In that case, you have to go either for video. I used to work in video. So in that case, I have to, if I am going to sample as a video clip, that means clip number 1 you sample to clip number 10, not frames. Okay.
If E is signal, sir.
Huh?
If E is signal.
Each signal, it has to be clip. But that means sequence. Okay. Otherwise, it will be improper. But if you are extracting the feature and going for a time domain, time window, that window can change. Because we know that by using that PQ RSTU, phantom kinetic algorithm, you can detect. If you are able to detect that, once you detect that segment, then segment wise you can do. For the same person, I have 10 minutes of ECG data. So one ECG independent can be interpreted. But within that not, time step. So here you can see it. So always remember this type of result should be given, because what will happen, we are giving multiple plus minus accuracy. This is the standard actually. Recently in my IEEE transaction paper they told me perform this experiment. I perform it, then I gave it. You cannot write because it is always, because machine to machine accuracy will different.
The video kind things.
Huh?
Video things.
Which one?
The testing is your video like.
No, I show here for the simple example, but I am telling that for my paper it was video. I used to work in video anomaly detection, but it's a quite difficult topic, and for that reason, it's not machine learning, completely deep learning, so I didn't cover it. So these are the findings. You can see bias data decides exploration. Inductive bias is a set of assumption learning makes to generate. It comes from hypothesis space, optimization method, regulation, even from the data pre-processing. If your data pre-processing is wrong, then model will be also wrong. Okay. So one thing I will tell, many people know that you have to develop a model. You have to develop a model. So try to develop an efficient model. Your accuracy will decrease. So that is wrong actually. Nowadays, there are two approaches for any model. For machine learning or deep learning particularly, there are two approaches for modeling. One is data-centric approach, another is model-centric approach. For example, keeping data constant, input is constant, try to improve your model by modifying the architecture, get the more accuracy result. So that is model-centric approach. Keep the model constant. Let us take ResNet as a fix. Okay, 51 as a fix. Try to improve the data using augmentation or using different pre-processing technique. Improve the accuracy, that is data-centric approach. In practical real-world problem, we used to combine it iteratively. Okay, so that is the dual approach. So always if people are getting some result, because we know that after a certain extent, the model fails too long. Okay, always by increasing number of layers, the accuracy will increase, it will not happen. It will not happen. Okay, because training large number of layers also difficult. So many concepts are there. Okay, so basically after certain extent it will be used. So that's why nowadays people are also doing data centric approaches. Because whatever concept I am explaining in inductive bias, it is 75-74 concept. Okay, 1975. But now I am explaining because why deep learning comes to because it is only due to efficient learning algorithm, efficient hardware. Otherwise, without data availability, everybody has a mobile, so everybody is a data source. So without that, you cannot do. So that is why data, computational platform, learning algorithm. These are three things. Then only machine learning deep learning comes to picture. Nowadays, we are also moving for quantum learning also. So another concept I will get why the simple method outcome the complex one. Many times we will see the simple models also outcome complex one. Many people think that complex model means better, always better. It's not like that. Common belief complex model dominate, but really depend upon the data regime. So I will explain one thing. Many people, my juniors, my colleagues also, my friends also, they ask me that I want to detect work in the breast cancer domain. So that is already saturated. I want to do blood cancer, that is saturated. That video it is saturated. And this region, video anomaly, it is quite new. No papers, no codes are available. It is difficult. Like that concept. Okay, you people are doing research. People will get. So remember from my experience, I can tell there is no saturation. There is nothing. It depends upon your concept. That even in machine learning, you can publish transaction paper now also. In deep learning, you can also publish. It depends upon application. For an example, you want to apply a model which will be a node MCU, okay, or simply ESP32 microcontroller. In that case, you cannot introduce the deep learning model. You need a simple regression model. Okay, for a particular application where your model size will be 5 KB only, 5 KB kilobyte. So in that case, your machine learning is sufficient. So what I am telling, any research area, any application, any model, any data has to be decided depending upon the targeted application. Targeted application. Second one is the desired infrastructure. I have laptop, so I want to do research. I want to publish because for my career growth, I have to publish. So what is my resource available? What is the data available? What is the deployment path available? What is the desired accuracy? From that, you can choose the accurate level one. For example, you are developing a machine learning algorithm which will be embedded inside the MRI machine itself. Directly, it will give the result for MRI detection. So yeah, there you cannot put that highly computational efficient system. So there are so washing machine. It has smart washing machine. Small programs are there. Okay, but washing machine case is lookup table. So that is different thing. Little bit of lookup table. Ideally, if I am able to perform hashing of all the data available in the world and create a huge large number of large size lookup table, so my all machine learning problem is solved. Okay, but ideally cannot do, practically cannot do. So that's why machine learning. Okay, so here, so simple model, basically bias variance perspective. So we'll explain small data with noise. It's simple models. Large clean data, complex model, stability versus flexibility trade-off. These things I'll explain. One hour, 30 minutes. Actually, 1 hour almost completed. Should I move little bit faster? It will take little bit faster. Sir, actually, if people are getting something, I will tell. Otherwise, I will. My intention is not to tell what you have learned. My intention is that's why I am approaching in a different way. And this is the first time for me doing this way. I used to take in FDP in my lab. Professor used to do take labs in a sequence way. But this way, because they are what are a combination of students and teachers comes. So here teachers come, so less time. So I plan in different way. One question, one answer like that, and I will also research aspect I will tell. So I will do little bit move, I little bit move faster because within 1 hour, if I will not tell, I will not tell the research aspect. Few things I will tell, a few codes I will tell, few idea I will tell. If you will work for 2 days, you will get a conference paper. If you will work for 1 month, you will get a journal paper. You may laugh, but I can tell. Okay, that is why I am telling. Because Initially, frankly, for my experience, initially for 6 months I used to take one conference paper. Now that's coding one day, writing one day. For me, so it is happens. You have to do conference paper. But no, nowadays we are not publishing actually. We are publishing journal only. So that's why because you can start. Everybody should start. But why I'm telling? Because you should get because nowadays all colleges doing mandatory publication. So that's why I'm telling. I will give some course. I will tell some idea. Even if you don't know, just paste that, tell that, explain properly, explain to chat GPT. That can do also code, but you should know that whether it is wrong or correct. Correct.
Sir, also you give us some technique that how we can collect a sample data. It is the one
Sample data means.
here whatever the program you are giving, you are giving some inputs. That is the sample data. How do you
On data sets,
Oh, you are telling data sets. Okay, okay. No. There are whatever program I am explaining here.
That is a primary data or secondary data?
This data.
Yes.
This data I am not. I am generating in my program itself. It is not like for example purpose only. It's a from that data generator. Random signal I am using na. I already told na nothing random is random. So that's why we told that pseudo generator in PM frequency. Pseudo random noise, not is random actually. So I am using that. But for data, if you ask, I will explain one thing. Where should you get data? Basically, lots of data portals are there. IEEE sites are there, paper portals are there, GitHub data are there, all some data are there. But even if you are working for weather data, government data, climate data, lots of data is there. Okay, time series data, also data. For video, specific data is there. So there is an approach. How to do in research? What you have to do? The best part is that if you can create a similar data set for your application. Okay, but if you create your data set, perform your research, write the paper, it will be get rejected. The reason is that your data is not benchmarked by others. So that is why the thumb rule is that try to at least follow 3 good benchmark data set inside domain. For example, for my video annotation, UCF Prime data set is there, Shanghai Tech Campus data set is there, another CHK Avenue data set there, 3 data sets are there. It is 95, 80 GB like that data set. Okay. So in that data set data, so I have also created from my department backside NIT connected CCTV and from 1 month from that I capture video and go for annotation, clip level annotation I done it. So that whenever I'm writing paper, 3 data set, our proposed data set. So gradually our data set is public. Gradually 1 or 2 years after my data set will be benchmark data set. And if you are publishing data set, your paper citation will be not in the thousands, it will be in the lakhs. In the lakhs. Per year you will get 1000 citations minimum if you have data set. Because people will use it. But it is a highly expensive, tedious job. So that's why people don't do it. But even am I correct, sir? So then here we are going to explain where the simpler model exists. You can see in simple data only logistic regression I have used. Here you can see 3 cases: logistic regression, cross validation, nested cross validation. Here simply logistic regression, strong bias, low variance, complex, random forest is complex because weak bias, high variance concept is there. Data regime, small noisy data set, small and noisy data set. If you have small data set, so that is why I will explain one thing also. That is why it is not necessary always go for the deep learning. If your data set is very small, go for machine learning. So here you can see for simple data set, my simple and noisy data set, small noisy data set, because if your data set is more and more consistency data set, then deep learning comes to picture. It will improve the accuracy. But if it is noisy, then whatever noise will be amplified throughout the layers. So that's why it is limited. So you see here, simple logistic regression, you get the accuracy, and complex random forest, you get the accuracy. So these are the things. Perhaps by using that full screen, it is getting distracted. I will use that one. Okay. So here, the when data is scarce, noisy and low dimensional, strong inductive bias, helps. That means if you have small data, then try to do some innovation in the pre-processing end. Some domain knowledge comes to picture. So that's why nowadays people are doing physics-based deep neural network. You may learn. You may in a deep learning papers to physics-based neural networks. Physics-based neural network means, for let us assume that I am creating a model underground GPR application, which will take my reflection coefficient through the horn antenna. From that reflection coefficient, I will care whether landmine is required or not. In that case, my data will be A scan, simple form, and B scan will be image form. In that data, if I am using as a simply deep learning model, so that accuracy will suppose 90. If I use some microwave concept, that means my Maxwell equation concept, that is my domain knowledge, physics-based knowledge, accuracy will increase by 3 to 4%. So nowadays, recent trend is that deep learning plus physics-based modeling. So that's why I'm telling you, if small data is there, always add some domain knowledge. Complex model amplify noise variance when simpler model stabilize only. So this is regularization. Many people tell that regularization, what is that? Regularization prevent overfitting. This is the answer, but this is the shallow answer. It's not depth answer. So it's a common expansion, but incomplete expansion. So what is the real selection? Many solutions are there. From that solution, it finds the perfect one. Regulation chooses the stable one. Stable one it will choose and control the geometry or improve the robustness. Robustness means validation or more accurate result over different on-sensed data sets. Yes. I'll move little bit to fast further. Similar program I have written here. So you can see, I will see the curve, you can see train loss, validation loss, test loss, and regulation controls over the threshold curve. So these are the curves, how the regulation coefficient changes with the picture. Then this is nothing but my weight parameter, how it is changing. So you can see regularization and unregularized linear regression. And in regularization case, you are getting more result, more accurate result. So that's why regularization is required. Because why I'm not telling all the theories clearly, because already you are studying. I'm telling the important parts. So here you can see similar training loss, different weight loss, validation loss minimized at optimal regression. Regulation does not just prevent overfitting; it selects a perfect or preferred solution among many that fit the data. It improves stability, margin, robustness. So next concept, can lower accuracy be better? Always we say that if your model is more accurate, accuracy side is good model, not always good. So it is a trap. Accuracy, by always looking the accuracy, if you decide the model is bad or good, it is a trap. It is not a 100% solution. So that's why, because model does not tell confidence, model does not tell the uncertainty which it can deal. Okay, for example, uncertainty means if the video processing application, let us assume that illumination varies, lighting happens. These are uncertainties beyond my control. So how will behave? Accuracy cannot deal with that. So that's why calibration is required. Calibration means some small data, you have to use that small data for at the test side only and try to use that performance to augment your performance, some small sample data. So any people from microwave background, EC background, if you are EC background, you know that stop matching concepts are there. In antenna, whenever you use the stop matching, the probe is connected by using short, load, then open connection as a open end. So you can move the propagation delay from that from that cable, RF cable to directly to the VNA port. Yes or no? So that is calibration. Just like in simple word, weight measuring every 1 year, 2 year, you have to again re-standardize it. That is nothing but calibration. So without calibration, instrumentation offset happens. So similarly, model in between, you have to do test and you have to accordingly you have to recalibrate your model. So that's why calibration is required. So better evaluation matrix, log loss, barrier score, calibration curve, and because we know that learning is probabilistic, because we are learning the underlying PDF, probability density function. Okay. So this is the same concept where you see the simple model gives better result. Simple model gives better result as compared to the last one. You can see simple model gives better result as compared to the last one. So you can see. I will share the course. You can go through it. No problem because I have to cover lots of things. That's why I'm just little bit moving faster because 1 or 15. I have only 45 minutes. Then, where bias and variance pairs. This is the important question. Many people till now always confused. What is bias and what is variance? What is overfitting? What is underfitting? Many people tell. So these are nothing but my classical view. This is U-shaped curve. You can see error is there, bias is there, variance is there, total error is there. So traditionally we see that with increase in model complexity. Model complexity means it increases only when the number of parameters increases. Number of parameters means number of neurons, number of layers, number of weight file, so many things are there. So basically, even if regression model parameters are there, so basically, whenever parameter increases, model complexity increases, computation increases, compute increases. In that case, at a certain point, you can see for optimal model complexity, total error is minimum, variance minimum, bias is minimum. After that, it is failing. After that, it is increasing. So that means you see, actually we need low variance, low bias. We don't need other cases or the fail cases I have explained also there. But in modern expansion, you can see basically double descent occurs. So that means after this, it is decrease, increase, again it will decrease. So that will happen in the deep learning when your data is more, your model is more. So that's why a classical U-shaped curve will not happen. So you see in model case, modern reality you can see descent, double descent refers to a phenomenon where test error first decreases, then increases, classical overfitting, then decreases again. Model complexity grows beyond the interpolation point. Then what will happen? Training error will 0. So interpolation point means that point, I have shown you the beach point, middle point. Then second descent will happen. That will give rise to perfect fit and generalization. So in a highly overparameter regime, increasing model complexity can improve generalization instead of harming it. Let us give an example. Basically, face recognition with a camera. For example, if I am going a tiny ML application, just like 94 cross 94 pixel size, in that case, my resolution is very low. So if resolution is very low, then another case I go for a laptop model where I can in laptop I will train medium resolution 256 cross 256. Then we go for 1048 or 1080 cross 1080 that high. Then what will happen? Model will go for underfit. When resolution is less, model will go for underfit. Model is medium. That means your parameter is more, but input is medium. So what will happen? It will give to overfitting. But parameter is high and also your resolution is high. That means pixels are samples I am considering here. So what will happen? Perfect fit will happen. So basically here what will happen? Low give rise to low resolution give to underfit. It is a practical experience. So medium will give to overfitting, high will give to perfect fitting. But what will happen to error? Error should happen classical, it should increase. But what will happen here? It will down, again up, again down. So it will double descent happen. That means twice decreasing happening. Descent means degrading. So powerful model stops memorizing noise and start learning the structure. So this is whatever I have explained, that simple concepts are there. You can see regression I have used. This is first one, you can see it is increasing again. That means interpolation region, the region where training error is 0. Interpolation threshold is boundary where the training error first becomes 0. So here you can see the basically explain whatever I explain, all the things are there. I'm moving a little bit faster. So these are the explanation I told you. Basically you can see up to this interpolation method, training error 0, classification, accuracy error is increasing. But after that, training error is 0, but it is decreasing. So this is nothing but modern overparameter region where deep learning, machine learning, or complex machine learning comes to picture. Okay. So statistical significance and reproducibility. So in any model, whenever you are doing some model, reporting some result, always don't report the result from a single number. I have one BTech guy made with me some experiment from some coding. He told me my result is 99. So I found that for satellite image registration problem, he has used only one sample. It has 40, only one sample that is there after that. So that means even if you are always try to give result for different cases with because it's a probability learning. So from that you should give distribution. How a result is good because results will vary with seed. If a randomness is different, result will vary. Data set split, randomness will vary. Result will vary. If noise addition will vary, randomness will vary. Another beautiful concept I can tell. Whenever you are doing any time series forecasting application, for example, temperature forecasting, weather forecasting, sales forecasting, crude oil forecasting. In that case, if you have a time series data, always try to add some Gaussian noise with small variance, small mu. So what will happen? Your accuracy will increases because your input data is more generalized data. So your accuracy will increase. This is one contribution we have already published. One so other things are there. Small part this is there. So already because noise is required. Many EC people know because without noise nothing is required because oscillator will not work. Okay, noise is required. Without oscillator no clock is there. Without clock no processor is there. So noise is required. So that's why I told you noise is required. So here also noise is required. So proper reporting in paper try to report in different way. So always try to report mean plus minus standard deviation, multiple rows. So that's why k-fold run, k-fold validation we are telling. Statistical tests. Nowadays people because recently in my paper I have done Feynman test. So what is Feynman test? So let us assume that you have developed your model and tested for 3 data sets. In 2 data set, your model is working good. In another data set, another existing model is working good. So how you justify it? So always remember, if you are comparing 5 methods with your proposed method over 3 data set, I need a single parameter. Let us assume that physics, chemistry, math, including I got here 560. So some mark is there. So single average point. So that can be from the Feynman test. From that Feynman test, you will calculate the critical distance. From that critical distance, you can rank the methods. If your method is 1, then it will make 1. So that's why if you are telling that in your paper you are telling my result is giving good performance in the data set A and B, but C it is second best. Still you are telling it is clear. Suppose you understand. In that case, you need a single parameter. So that's why nowadays, particularly I can tell computer electrical engineering journal. Then another is industrial IEEE industrial transaction. They people are directly they have a editor report. Directly these comments are getting. You have to give the result. Directly, preset. First comment, editor will send means it will come by default. So that's why I'm telling, always try to add some statistical result. Apart from that, what I am explaining, all the things is required because many people are writing before, many people are giving testing results. Okay. So that's why you will see, apart from that, many people are not using mathematics formulation. In my PhD work, what I have done, I have created my simple one neuron, one cells, not layers. I am not used the pre-existing LSTM layer, something like that. Cell level I have used. So for that mathematics. So if you are able to derive the mathematics, okay, so it will come. So basically mathematics is nothing but because suppose I am telling it is good for me, it is may not be good for you. So it's a normal language interpretation. For mathematics, it's a scientific symbolic language where it will always have a consistent meaning for all persons. If I am telling it's a sample space S, for me, what is the sample space? For you, it will be sample space S. So that's why in machine learning paper, deep learning paper, many people don't do mathematics. Try to do mathematics. If you want to see mathematics, you can see few of my papers. You can see for deep learning paper, problem formulation. I have given 4 to 5 pages of problem formulation. All the expression, all the mathematics are there. So if you are able to convert, because many people tell deep learning is black box. Actually, it's not black box. We don't know how to make it transparent. So that is the problem. So that's why people are doing explainable learning. Okay, by using the graph terms, so many things are there. So we'll go to similar concept, statistical paired value, difference key value, p value is there. So many things are there. Within 5 minutes, I have to complete this. Then representation classification. Representation is nothing but my feature extraction process. Classification is nothing but my classification, which class it belongs to. So basically, in raw space or raw sample space, my data are mixing sample space, so I have to classify it. So basically, future space has to be, or feature space or latent space, or in a higher dimension, it has to be separable. So that's why good representation is easy for classification, bad representation is not good for classification. Okay, so basically what I'm telling, suppose I'm telling that you are developing a model which will have a good feature, which have good feature extraction, and it has a bad classification. So let me clarify you. In machine learning, we go for the handcrafted features. We do our feature extraction. That's why in automatic feature extraction, deep learning comes to picture. That is the beauty of deep learning. So deep learning is good at feature extraction, but it's not a good classifier. So that is why you always try to do something new. What do you have to do? You extract features by using deep learning, deep neural network, and classify using some random variety of statistical classifier. So that is hybrid approach. If you do that, you will get the paper published. We have few papers on that. That's a hybrid approach. So for example, I will tell that it is a suppose some pollutant level of the river. You want to predict, or you want to classify. Okay, in that case, what will happen? You try to extract feature by using deep neural network. For example, ResNet, LSTM, CNN, you use that. But classifier, instead of outside the segment, in the output layer, you just go for RBF, SBM. Okay, so many things. So that is the one idea you can do. People are doing it. It's good. So this is the same concept what I explained. You can see, actually I have to cover one. So you can see linearly concentric circle problem. So I have to separate the circles. Okay, small different classes, inner circle, outer circle problem there. It is actually available. So you don't worry about to understanding the code. I have written the comments. I have already explained the concept. I will forward the code to the coordinator. He will share with you, no problem. So last one I will explain the concept. So because I have to complete so many things. So data set varies because basically you have to check the data set bias and sanctity because shortcut learning basically model achieve high performance exploiting the spurious correlation of shortcut rather than learning. Okay, basically misleading data. That means you are seeing that model is giving good just I told you na small data only one sample giving good result, but it's not good result. Na? So that's why I'll tell the example so that you can understand actually. The example is that in simple real world example, let us have that a cow horse classification. So my model has a cow image, all the green field. Horse has image, all the brown field. Green field is background. Here brown field is different. So my model may learn green field as a cow, brown field as a horse. So in that case, if I am learning that program, so what will happen for me, green field and brown field are not labels, but there seems to be labels. Yes or no? But cow and horse is level. Yes or no? So that's why in that case it's nothing but my shortcut learning happens. So that's why you have to check the data sensitivity. You have to check that. So how to do that? Level suppling, feature ablation, noise injection. I told you that time series forecasting you can add the Gaussian noise. So these are the. So basically another thing is that always try to do permutation analysis. Permutation analysis means, for example, suppose I am important among you. So by removing me, if you are your effectiveness reduces, then I am important. Yes or no? Let us example Modi cabinet. By removing Modi, if BJP is not able to win, so Modi is important. So in that case, try to feature wise drop something and change the performance. Drop something, change the performance. That means feature. So which feature the result is less, degraded significantly. So that means that is more important. So that is one approach. Okay. So these are the ways to check the data sensitivity. So this is nothing but my permutation results. Basically that horse samples and data set are there. So you can see. So I try to complete a little bit. So the reason is that I want to explain another. So thank you. So in 30 minutes I will really tell. First 10 minutes, 10 to 15 minutes, where you will listen carefully. Okay, so you can at least do some work, at least publish somewhere little bit, because I am giving the base code, I am giving the ideas, so you can do that. Apart from that, I'll implement two pipeline, TinyML pipeline also. Two things I have to. So I'm closing it because my GPU is highly. One important thing I want to tell: whenever you are creating any application or any project or any module for your practical deployment, or let us assume that, because nowadays any transaction paper, any good paper, they need a little bit of hardware, practical implementation. Even if you are showing directly PC and laptop connection with real-time performance photo, something like that, that is also they are accepting. Because without that, because how you are going to make different from others. Okay, so that few things are there. So if you are targeting for developing any model, let us your deployment platform is Jetson. Your deployment platform is Raspberry Pi. Your deployment platform is NVIDIA or different platform is there. So in that case, what will happen? Before creating environment, always try check the official page, GPU compatibility, TensorFlow compatibility, Python compatibility, everything check. And after checking it, try to install the environment in your deployment device first. That means Raspberry Pi first. If you deploy that, then test the simple code, whether GPU is working or not. NVIDIA is working properly. Jetson Nano, Jetson TX2 is working perfectly or not. Your ESP32, Arduino BLE Sense is working perfectly or not. If it is working there, try to create the requirement.txt file there and create that text, take that requirement.txt file and create same environment in your laptop or workstation. Then you run, then train a model here, then convert, then deploy that. People do here. After 6 months, they are unable to deploy. I have hosted 6 to 7 months there. That's why I'm telling. Whatever I'm telling, because your target is there. So try to, because your hardware, your laptop or workstation is a complete waste. But that is a bare metal. Microcontroller is a bare metal, active OS only. No complete OS. Even if that NVIDIA, Jetson, Raspberry Pi, all stripped version of kernel Ubuntu. Okay, so that's why I'm telling. So these are the few things. So now I will give something. One simple use case. Actually, I predominantly work in a deep learning, but little bit also few students they come work with me. BTech students, we also do some machine learning work. So this is one of the example which is possible to publish good work in your laptop having only 4 GPU GP, 8 GPU RAM, i5 generation. That's not sufficient. That means 50,000 your laptop can survive. Okay. Why I'm telling it? Because my model, I used to work in 24 GPU, 2 GPU card, 128 GB RAM, and that workstation, my PhD data is around 38 TB. 38 TB data. So nowadays, actually, I'm really struggling to get hard disk so that I can take backup. I'm requesting to my professor to keep the backup so that I can, after my joining somewhere, I can take the data because I have already purchased 10 to 15 hard disks. Okay, so that's why I'm telling. So that's why I'm telling you can do here also. Why I'm telling that? Because recently I come to all of a sudden I found that once I getting out of this institute, then what I do? Unless until join somewhere I got a good platform, so my research will be postponed. So that's why I try to diversify it. So that is why I'm telling. So always try to do some machine learning. Suppose let us assume that here I will one research aspect I told you. Here we are going to do predictive maintenance. Predictive maintenance is nothing but let us assume that steel power plant is working. So you have connected sensors here. All time sensor data is captured in the processor. So based on vibration, noise level, and that oil leakage, sound, so many pressure, temperature, so many parameters there. From that parameter, you can predict where the system needs maintenance. Remaining useful life you can predict. Okay. So if you can predict that, so a sudden breakdown can be prevented. If sudden breakdown to be prevented, you know that to start a steel plant burner, it requires 1 month. So 1 month your production stops. So that's why scheduled maintenance is always required. So that is why predictive maintenance is very important. So in that case, why I am telling that this simple model can be deployed in a small Raspberry Pi. Okay, small Raspberry Pi, small model, APJ board, you can deploy and the product has sellable actually. Okay, so here, so let us assume that what people are doing machine learning. So if you are doing machine learning, let us assume that in deep learning what happened? Many people will tell, just decrease layers, activity layer, activation layers, something changes, you will get a new architecture. Many people tell, but that is not the fact. But broadly, few people do that, but that is not the fact. But machine learning, that changing is also difficult. Okay, so that is why you should use your domain knowledge in that picture. So whenever I am going to find here the domain knowledge in predictive maintenance, the domain knowledge comes to picture. Yes, sir. The cost associated with the industrial maintenance have extreme asymmetry. That means when the economic penalty be for false negative, that means missed failure, is significantly higher compared to that of false positive. No instance alarm. For example, I deploy a device, actually breakdown नहीं है, वो alarm दे दिया, मैं जाके देख लिया. I just want to check. So what happened? I got irritated or something resource happened, but it's minimal. But actually breakdown already happening, damage happening. It is not telling me sudden complete breakdown happened. So it is cost asymmetric. So that means here if cost is penalty is 1, then it is 30. Understand? So this is the data set concept. So this is the domain knowledge. So if it is domain knowledge, so I want to use that domain knowledge in my model. Okay. So to create a new model. Okay, so now I will create a new model. So you see here. So I know GPM model is there, gradient boosting cluster is there. Yes or no? I also know LGM, light gradient boosting machine. So basically decision tree, multiple levels of weak learners are there. Multiple levels of weak learners are there. From leaf you can minimize. So LGM already perhaps they have taught it. Okay. Okay. So in that case, this is my machine learning. I know. So now I want to add my domain knowledge. So if I am able to add my domain knowledge, then I will find the paper. I can do the paper. So here, what happened? So I propose one technique where cost sensitivity thresholding. In machine learning, LGM, the 0.5 is the minimum threshold actually by default. Threshold to decide. So here, my threshold, I am controlling my learning the threshold by using the cost. So that means indirectly, I am training the model that I can permit, I can bear my false positive, but I cannot bear my false negative. So that's why my loss function will be different way. So in that loss function, if I am going to train, then I will get the result. So in that case, you will find that my overall FNR, false negative rate, will reduce. False positive rate will not significantly increase. So this is the nobility. So if we are going to do, so here these are the data set we have used. So basically this is the data set. It's a milling process classification data set which is used for XAI means explainable AI learning. So data set has 1000 number of samples. Each represents hourly observation of machines performance over the course of the 1 year. So the target variable is the binary machine failure, where 1 indicates functional breakdown, 0 represents normal operation. These are the levels, 1, 0. So from that, I found that this is always remember, this type of analysis, always where anomaly comes to picture, the data set is inherently class invariant. For example, I want to detect whether accident happens or not. In that case, if NH data set I am covering 24 hours, 1 minute may not be accident data. So inherently my data is class imbalance. So for that class imbalance, I have to also add. I have to address that also. So based on that, these are the failure modes. These are the data sets. So I will directly. What happened? Okay, no problem. Are you people be following me or I'm getting bored? The problem is that I feel that I am taking quantum jump. That means somehow I want to tell little bit smoothly, coherently, but due to lack of time, I am going from X to 1 to 5 step line. In between 3, 4, I am leaving. I am confident that I will share the codes. You can see the codes. Hmm? Okay, I will explain this 10 ml. I will find only 5 minutes. How much time is it?
And it could be 1 hour 45 minutes.
Now, how much time is it?
And you finish it because this like time is
Okay, okay. Actually, as
next
per
session starts at 11:30.
okay. So I will take 10 minutes. For tiny email, I can directly explain or share the codes with you. If people are share because time constraint there. I will explain this. After that, another concept, I will explain the brief pipeline. Then I will directly give the code and tell the folder wise because okay, I will do, try to that. What will happen? Because 10 minutes only I have 10 to 15 minutes. Okay, then. I'm directly showing the proposed model without showing the application study result because all codes I will share with you. Okay, this is you see this is the code. Oh shit, sorry, this is not IPython. Sorry. Just I'll do. Actually, here everything I have typed into it. If I used to Ubuntu, so many comments are I can use directly by using arrow. But here, I told you explain the code actually. So VS Code is independent of ID. So you can select the. So this is my model. So basically what happened? So before that I will explain one thing. So I told you here, see you see here, this is the one of the paper actually. So you see here, I show one thing. Just one thing. Instead of using normal loss function, we have used this loss function. This is my domain. I told you now. CFP means cost for false positive, which is 1 for means false positive in the theta. Theta is nothing but my threshold. And CFN is false negative. FN theta is not one. So this concept, this loss function, this objective function is added in the loss training itself. Okay. So what will happen? Here decoupled during training we have added, we found that ranking loss decreases. There are two types of ranking performance. AUC is ranking performance, that FP, AUC FP, but the precision recall are the detection performance. Okay, so detection performance remains constant. So that's why what will happen? We'll make it decoupled. That means this function will not added in the training. It will be added in the testing only. That means some type of calibration mechanism. So that's why this is decoupled. So I have shown you. So here you can see these are the performance results. Basically GBM 0.970, CST GBM 0.93. You can see here 9679 you are getting decoupling. Without here FNR is reduced, precision is increases, and your cost also increases. So many analysis there. This is one of the paper actually. Okay, so these are the technique explanatory. Here we have a proposed explanatory. This is a permutation method. I told you na, by reducing one, removing one feature. Here we have removed one feature, changes the more that line is there na, torque is more important feature here. Okay, similarly. So basically this is nothing but my code here. So you can see here I have given the path, and Ubuntu we have to we don't give the R because Windows we have to give the reverse. So here cost I have defined here, this is positive cost equal to 30, because this 30 I am not giving randomly. Data set explicitly mentioned the cost is like that as per their application. So this is a standard benchmark data set available in the IEEE, also GitHub in the Kaggle also. So from that, what we have used, different live GM parameters we have used. Okay, from that live GM parameter, different data set we have used. Here cost testing threshold, post hoc only. Post hoc means only testing. So you see here we are calculating positive cost for each step. Just like in ROC, we are calculating the TPR, APR for different threshold. Similarly, for each step, we are calculating the cost. From that cost, the best cost, which will give the best cost. That cost is nothing but by combination of that equation. Sum of that equation I have shown you. So that cost best will give that. So from that, we are calculating APR, false alarm rate, equal error rate we are calculating. That is APR, TPR is equal at a particular rate. That is just like in production management, we told that break-even concept. The point at which sales is equal to the input is equal to output, the revenue. Similarly, here the TPR should be equal to APR. The point it is known as point equal known as equal error rate. So from that you can see all the algebra, no cost, different trainings are codes. I will share this code, no problem. So and here I have applied the SAP method for that permutation methods. Then embedding, I want to visualize the results. So if I do that, so if I run, it will take time, but I have results, so I will show that directly. The codes are stored here. You can see for test. This is my ROC curve. Similarly, embedding is nothing but my feature space visualization. You can see visualization of the feature space. Similarly, metrics, all the metrics I have always tried to store all the results this way and show you, because many times you have to reuse the curve. And always one thing I will show, this model, I have told the model also, the tree structure. You can see tree structures are there. Model parameters, tree structure, tree 1, tree 2. Okay, these are things. So I have stored. Then apart from that, you see .np I have stored. What I have stored? In machine learning, what happened in MATLAB, communication people, those who are doing research, or particularly any wireless signal network people, they create the random signals or some data set there in MATLAB by using the toolbars, they run it. So exactly they get data set. But here, let us assume that you have to compare with the previous one. You have to run that. So you have to say, because in a single pipeline you cannot run all the codes, because all code have different environment. Okay, that's why try to store the result in NumPy, then try to use that NumPy file to plotting the results, so that comparison result will come a single plot. So why I am telling NumPy, not CSV, not Excel or any format, because it will create problem, because always remember I have faced that problem. For ROC code, if it TPR APR you are sharing, what will happen? If you are not storing by .npi, the order will changes. It is my experience, because I found that from CSV I used to store CSV. I found that, so that's why I use NumPy app. So these are things. So if you want to just so basically I will run parallelly, and I will explain another concept. The reason for running that, to show that it is only taking 1 or 2 GB GPU. Oh, sorry, sorry. I didn't move the holder. Okay. You see, only few times it will take, it will run. Almost completed. You see here. For validation, we got the 249 cost and test speed. We got the purpose. You can see. So significantly, the basically the same result is stored. So now we'll explain. I will tell you one idea beyond this. What you can do. There is one concept known as conformal mapping. It's a mathematical concept. So basically, by using conformal mapping, simple only by adding, you have to write a script for a conformal mapping. It's a mathematical function, mathematical concept. From there, you can map your feature space to the decision boundary. By mapping the feature space to the decision boundary with proper synchronous way, you can publish one paper. It is conference paper. But now it will be converted to journal paper, particularly for IoT sensor journal, IEEE. So how you do? You just do that. Once you do that, try to convert that model you into a .h file or C file and deploy that model using Arduino BLE sense. In that BLE sense, if you are deploying that, after deploying that, you try to measure the total memory consumption, power consumption, computational in class. It will be 5 kb, 6 kb file. Apart from that, power will be some milliwatt and very, very less. It will self-sufficient. In that case, you deploy that indirectly. No need to, always remember, no need to do the real-time testing in the sensor, the plant side, no need. You can able to do that one, and there is a concept known as a few terms I am telling, just note down, you can show tens, memory tensor arena or memory arena, tensor flow. By using that, without using the dedicated hardware, power measurement hardware, you can also measure that hardware using the serial port of the Arduino. Okay, so that will give rise to the, you will complete write this, that means your simple machine learning program now converted to a mathematical formulation with a nobility introduction. After that, it go to the deployment. After deployment, it's not deployment, it is deployed in a energy, power, resource constrained environment, which is microcontroller. Inside that microcontroller, you are giving a VLSI perspective, embedded perspective of that. After that, it will be a logical flow diagram, and logical flow diagram always give a UML diagram, unified modeling language diagram. Your entity will be left side, your entity will be the sensor side, outer user space, arrows will come, UML, you directly try to, because why I am telling, because how you are going to get the publication. So ultimately, by doing so, this is one data set, try to give another data set. For your simple case, create a one small data set that is temperature, acquire temperature of the your lab, or capture it, predict something or something related to seminar environment, at least two variable, one variable, give your own data set, complete result analysis, mathematical solution, ablation study, statistical analysis, it will be IoT journal. This much only. Okay. And whatever I told you, it is easily possible because already parallelly I am working on that. If you think that I have to publish, I should not tell you. But I am telling because everybody should do, attempt a different way. And the problem is that. Okay. Am I correct? Just 2 minutes. Okay. Just 2 minutes, 2 minutes. So this portion, actually I was to take the pipeline. So this is edge intelligence. So what I told you, you have to add the edge intelligence with IoT enabled edge intelligence. Wherever IoT added something, IoT, artificial, AIoT, something now, IIoT, industrial IoT.
Is intelligence is part of is computing, I think.
is computing.
Yes. Whenever edge computing added with the artificial intelligence, edge intelligence. So in that case, we have a basically we have constant, low latency, privacy, robustness, efficiency, constant power, compute, memory, cost. Here platforms are there. Basically, edge AI refers to the different edge device. When I'm telling edge device, these are the microprocessors. Basically, your Raspberry Pi, gateway, camera, all the things. Tiny metal, where I'm telling, this is nothing but a microcontroller, where no OS is there, bare metal. So severe extremely constant. So here paradigm are different. You can see all the paradigms I will explain. I will share the slides also. So just to already they have a group, WhatsApp group.
Yes.
So I am sending one link. You just share to them so that they will appear it. What happened? It is telling some. So in that case, so what will happen? Basically, you are developing a model. Once your model is trained, you have to go for pruning. That means number of neurons or weight you have to reduce. Then you have to go for quantization, int8 quantization. That means your number of feature representation will be reduces. Your feature representation will be reduces. So apart from that, quantization. After quantization, you have to go for TF converter. TF converter means you will convert your program into TensorFlow. Here you have to go for TensorFlow Lite, TensorFlow micro. Convert that. Once you convert that, you will save the file in .c file. That .c file will be used to write the Arduino program. In Arduino program, that will be taken as a pattern array only. So that Arduino program will give the result. So basically, actually, I am very much interested to explain it, but the problem is that
Scroll it. Scroll it.
Program is laptop.
ना ना नो चेंज कले हे जाउची कोन आई डोंट नो लैपटॉप में लगा काम
लगातार
हां होची बा मो सारे को कहि यू सी this is nothing but my pre-processing where I convert the image into particular resolution. Just I am explaining the code. So here my training pipeline. You see here model is I define the model, then quantized, then evaluate, orderly tested. Then once evaluated, then I am going for export. Inside export, you can see here these are my TensorFlow Lite file, then H5 file. These are nothing but my Arduino file. I have converted. Then C model you are got the header file, which will be loaded in the Arduino. Then after that, you will get to scientific check and this is nothing but type apply to header. All the pipeline is there. I will give as it is to you. It is all working code. If you want to, if anybody want to spare time, I can explain. I have already all the hardware in my bag. I can explain, show them so that you can get the idea to how to do that.
Kindly share the
I will share, no problem. Actually, nobody share, but I will share, no problem.
sir, age intelligence.
तो प्रॉब्लम है मेरा व्हाट्सएप बंद हो गया अभी इसमें नेट चलेगा क्या चलो चलाना एक बार नेट चलाना I want only 5 minutes of yours. I have prepared a quiz 10 minutes. So you just in your mobile, you just give your results and automatically you see your result. No need to tell me whatever I taught, all this is there because this is a self-evaluation only. No, actually solo from my due to that time counter my mobile got hang.
हाँ सत्य ना आज टिक लेट हो कॉन्सेप्ट में क्लास
नेट चल रहा है ना तुमरो ईमेल कहबो मु तुम ईमेल ले पठे देबी तुम ताकू पठे दो बुझि पाछो
मोबाइल कौन चल
मोबाइल मोर हैंग हे गला कंपनी जो टाइमर टा लगे थली स्प्लिट में हां खुले ये तुम नंबर कहलो हां 94390 889 77 है पठेलो असला than me just like my Just it will take 5 minutes. Please answer. Please answer. It is not about me. It is about you. Okay. Please complete the test. Check your score. If you are getting greater than 8, that means I will tell that at least I have conveyed something. This is not for you. It is for me. Whether I am able to deliver or not. You got the link? Just appear the test.
Some questions are there.
हाँ और एक लिंक दे रहा हूँ उसके बाद हम क्वेश्चन करना अभी से मत करना इसमें 8 से 20 मिनट don't think give randomly no problem because ultimately you get the answer also हो गया only 4 people are going 2 people please give ideally it should take 5 minutes ये जो है डाउनलोड करके रखो आंसर सबमिट करने के बाद देना अभी देना आंसर मिल जाएगा सबमिट करने के बाद whatever I explained it's based on what that only time ही ना share no problem share हाँ let them complete let them complete
Picture also ना.
सारा share ना
How also.
por ellos muchos saben que no saben que if people submit, no problem. Whenever you submit, also I have a take leaflet. Whatever I have explained, few concepts I have prepared a PDF. Once you submit, he will share after 30 minutes. Okay. Apart from that, code everything. So I will organize it properly. Within 1 hour, I will mail it to him. So he will share. Okay. Because randomly it has to be clean, little bit organized. Everything organized, I will share. No problem. I will share everything. So बंद कर दिया Okay, just one figure, one second. So anybody want any query or something like that, you can contact at me. So this is my contact. So if you want, so So let us find out. I would like to get any honest feedback. If you want to, if you learn something, just tell us. Otherwise, no problem. I tried to cover so much thing in few time. The problem is that I could not go line by line of the code because of time constraint. Even if tiny ML, I cannot explain properly. So I'll share the course, also PPT, and also the material.
मेरे लिए पठे देंगे
Just possibly,